Hello interwebs, welcome to Let's Fix Computers. This is an Xbox. So this Xbox came in not powering on. Now I don't know a whole lot about console repair. I replace HDMI ports, but you don't need to know a lot about repair to replace ports. You just need to know how to solder. But when it comes to Xboxes, when they just won't power on, stone dead, a lot of the time it's just a bad power supply, which is this fella here. And so I booked this one in. I was like, cool, I'll just put a new power supply in it and she'll be right. Unfortunately, it seems that that's not the case because I've got a used power supply that is sold as fully working from eBay. Same fault. So either I've bought a bad power supply or the power supply isn't the problem. And I'm 99% certain that the power supply isn't the problem because I did a little bit of further digging and found more, which I shall show you in a minute. So we're picking up this repair in the second act where I've basically gone, balls, this is not the easy job that I thought it was going to be. Let's see if I can pull this one out the bag. And hopefully this will be an interesting lesson in applying known skills because at first I think, okay, I have no idea where to start with diagnosing an Xbox that won't turn on. But then I stop and I think about it and I think, okay, what do I know? Well, I know how to fix laptop motherboards, and the Xbox is not a whole lot dissimilar to that. You know, this power supply seems rather funky with its two-prong output, but, you know, when we actually look at the output, it's just a 12-volt output on it. This is just a 12-volt power supply. It's not really any different from a laptop with a 12-volt DC in jack on it. It's just the power brick is just here, and it's inside the device, going down into these two prongs. So what we've got here is just a laptop motherboard, and yeah, I know how to look at those. So what do we do next? If we've got a device that does not power on, we look for short circuits. So what I then did is I turned on my multimeter, and I started poking about. So first of all, so if we have a look just under here, you can see there's CPU vCore there. We've got a row of inductors and a row of MOSFETs, and there's some input capacitors here and some MLCCs there as well. So we can measure the main power rail from there. So let's stick our multimeter on that. So I'll just go for this big capacitor. So that big boy there. Okay, not shorted. About 11, 10k, something like that. What about the little capacitors above it? Those are up in the megohms, same deal. Okay, no luck there. Is the actual input shorted? So which side is power and which side is ground? Well, I'll put my black probe on a known ground, so I'll just put it on the ground point of one of these capacitors, and I'll just stab both these pins. So that was dead zero, so that's the ground pin on the left toward the center of the console. And on the right-hand side, we've got like megohms. So the input isn't shorted. And likewise, you know, there's another capacitor right there. Again, we've got kiloohms there, so that's fine. Okay, so our main power rail isn't shorted, and the input isn't shorted. So we've probably got some more to see underneath the heatsink, but before we go that far, let's just poke around at other things we can see. So I'll put my black probe on ground again, and I'm just going to start stabbing any capacitors and inductors that I can see and see if any of them pull up as a short. So let's just start looking. Kiloohms, megohms. Oh, I think that's a beep. That's a speaker anyway. I think I got that one already. No. Okay, what about this inductor? Aha! And here we find we've got a short on this inductor here. What is this inductor doing? I don't know. However, an inductor with a little chip next to it and a bunch of capacitors, this is some kind of secondary power rail. So we found a secondary power rail that is short, that is in a dead short. So now we have something to start working with. So let's roll the intro and we're going to see if we can figure out what that secondary power supply is. This video is sponsored by FlexiSpot. I've been using FlexiSpot standing desks for a few years now, and they've been a huge quality of life upgrade to my workshop and my home setups. This month, FlexiSpot sent me one of their folding desk chairs as a great addition to my home desk. And now when I switch to standing, the back just folds down and the chair can roll right under the desk and out of the way. With adjustable lumbar support, headrest and reclining back, it's affordable and ergonomic for offices and gaming setups. At the shop, I've been replacing all the old temporary benches I threw together in the early days of the new shop with FlexiSpot desks, and now they're stable, adjustable and give a professional look. Being able to lift up to 120 centimeters means I can work on desktop and laptop computers without having to bend over them, and in the same beat, they'll readjust to sitting height. Check out the FlexiSpot website for their range of desks, chairs and much more. They provide free shipping in the UK and a 60-day money-back guarantee. Learn more in the links down below. So here's a closer look under the microscope at that area. And so once again, you can see we've got a secondary power supply here because there's an inductor, there's a regulator, and there's a bunch of capacitors around it. So let's see if we can sort of figure out what's actually going on here. Most motherboards are going to have a 5 volt and a 3.3 volt regulator on them. Because a typical computer has got a main rail that is going to be like 19 volts, somewhere between 10 and 20 volts typically, depending on what it is. Then you're also going to have the 5 volt rail for 5 volt logic and the 3.3 volt rail for 3 volt logic. And we've got this guy here, and then there's also another regulator over here. We've got this big inductor and another regulator down here. So I mean, I don't know what this, I don't know if that's our 5 volt, but that could be our 5 volt reg and that could be our 3.3 volt reg, with the 3 volt being the smaller one. I might be wrong. I have not looked at a schematic, but for the time being, it doesn't really matter. They're secondary power supplies. The specifics are irrelevant right now. So let's sort of decode what's happening here. The inductor is always going to go on the output. So if we have a look at what connections we've got, this is going to be our output through an inductor, which goes off to wherever. And then we've got some output capacitors there as well. Now, the capacitors on the output here need to connect to ground. So immediately we can tell that this is going to be a ground plane here. So that's providing a ground connection into the regulator. And this also swings up to this big fat ground plane here, which all these other capacitors are also linked to. And so we can start validating this. I'll put my black probe on a ground point and we can start confirming this. So if I just touch one of these, you'll see that we've got dead zero, 0.05. So let's check the input side then, because if we've got the output and the ground, this has to be the input coming from our main supply. So our main supply, which is 12 volt, that's not shorted. And that tallies because we didn't see a main rail short anywhere else. So that's what we're expecting. So then here we've got ground as expected. And then on the output here, when we measured here earlier on, we've also got 0.09 ohms. So that's functionally nil. That's a dead short to ground. So the question is, of course, is the fault with this regulator, or is it something on the output side? And well, we've got three multi-layer ceramic capacitors on the output here. And around here, it's always a capacitor. So what do you think the chances are that it's just one of those? Well, let's have a real close look and see if we can spot something. I'm just going to try and angle this thing up. I haven't even taken the board out yet. So let's go mega focus. Alright, there's some discoloration there, but there always is. I can't see anything screamingly obvious on that side. Can we get a look at the other side of them, I wonder? The one closest to the inductor we can't really see. Hard to tell. Okay. So what are our options here? Well, we could figure out if it's the regulator chip by removing this inductor, which isolates the rail from the regulator. So if we take this guy off and this bit is still shorted, that tells us that this chip has to be at fault. I mean, or well, we've got a tiny little capacitor there as well, but this is most likely some kind of feedback circuit, so that's not going to be it. So we could take that guy off, or I could just take a swing in the dark and just take these three off and see if it's one of those. So let's do that and see if we get lucky. And like the lesson that I want to impart here is that if you have some basic knowledge like this that you can use to start diagnosing, then maybe you don't have to switch your brain on. Maybe you don't have to look up the schematics. Maybe we don't even need to know what voltage rail this is, because we know that these capacitors are always a problem, and we've got the means to very quickly remove them and try our luck. Right, so I'm just going to wet these joins with some fresh solder. Then I'm going to come in with the hot air here because we're in the middle, so there's nothing super delicate nearby. And because I've got to take off 3 of the capacitors, it will actually be easier to just hot air all 3 of them off at the same time. There we go. It's a heavy board, this. And how lucky am I today? I'll put my black probe on ground. And I'm not lucky. We're still shorted. Okay, it's not those capacitors. Womp, womp, wah. Very well. Okay. I think I'm actually going to have to take the board out of the chassis. But first I'm going to put those capacitors back on. So let's put back what we took off. Damn, I really thought it was going to be that easy. Okay, right. The rest of it's coming apart. Right, well, it wasn't any of those 3, but I can tell you which one it is. It's that one. Let me stick that under the microscope. Now that's a cracked capacitor. You love to see it. So we're directly on the other side of the board to where we were. So these are also output capacitors. If we looked on a schematic, we would see a bank of like 7 of these large ones there. There's 4 on the bottom, and then there is the 3 on top that I just took off the board. Then there's also a bunch of those tiny ones there. And for reference, all of those tiny ones, those are going to be like, picofarad capacitors and stuff like that. And those are all there to catch high frequency noise and EMI and stuff like that. So this is a buck regulator circuit, and the output is actually being switched on and off at very high speed. It's chopping a high voltage input into a lower voltage output. And that high frequency on-off cycle gets smoothed out by the inductor and the capacitors. The inductor resists a change in current. So as the output switches on, this guy resists that and smooths the sharp increase into an upward slope. And then when the output switches off, the inductor discharges, creating a downslope instead of a hard cutoff. So instead of having just a square wave output, we're sort of pushing lower into a wavy output, and then the capacitors are resisting a change in voltage, and those are then further smoothing things out, stabilizing the voltage at the high point. So as the voltage drops on an off cycle, the capacitors are discharging, and then as the voltage is increasing, they are recharging. So you need a lot of bulk capacitors at the output of your power supply to smooth all of that out. And then the tiny little ones there, those ones are not providing any of that sort of bulk capacitance. But because we've got because we have a power supply here that's switching off very fast, that's creating high frequency noise that will couple through to everything and create interference. And these tiny little capacitors, those are there to catch that high frequency clutter. Those tiny little ones, in my experience, you never really see them fail. The only thing that's going to cause problems with little capacitors like that is like if there's been liquid damage or an actual reason to corrode. The bulk ones here, like these 10 or 20 microfarad capacitors, those are the big heavy lift boys that are doing all of the grunt work, which is why they are more susceptible to failure, because they're doing all the work. So our actual failed one here, we've got our output is that center bit there, and then surrounding it is another ground plane. And I can tell straight away that the center is the output and the outside surround is ground, because it's going directly on to this big flood ground plane that occupies most of the board, and is the sole reason why these boards are nightmarish to solder onto, because you're basically trying to solder on an anvil. So, with that being said, let's try and get that guy off the board. So once again, I'm just going to touch up those joins with the soldering iron, and that will just make them a little bit easier to desolder, because there's some fresh solder there, just lowering the melting point, and also just to burn through just the layer that builds up. I don't think production puts any kind of conformal coat, but I don't know, you get this kind of lacquer over solder joins. I don't know enough about production to know what that is. I don't know if boards actually get lacquered in production, but at any rate, yeah, just wetting the join with fresh solder just makes it a lot easier to work with. I'm going to take off that one next to it as well, because I need to know what rating these things are. Yeah, so you can see these ones that I've not touched the joins on, they're a lot harder to move. Yeah, let's just touch those up. I could brute force that off, but I don't want to damage more components, so we'll just get some fresh solder onto those. That should do. So firstly, I'll put my black probe on the ground plane, and we're going to check if we're still shorted. And there we go. As you can see, our short circuit is now gone. All right, and it is 22 microfarad. So they're 22 microfarad capacitors. All right, and in a surprise to no one, the really bad-looking capacitor is shorted. There we go. Cool. I am once again making another video about a device with a bad capacitor on it. But if I have to give the same lesson 100 times in order for people to learn how to do this, then it's worth doing. Because if you learn how to do this, you will fix many devices. Okay, I'll touch some fresh solder onto those pads. Put down some flux and then we'll hot air those two capacitors back on. There we go. I'm just dragging on all of those pads. One of them obviously we're not going to use, but that doesn't matter. So, whoop. All right. Now I'm starting from a long distance with the hot air because I don't want to blow them away. And I'm just going to gradually heat things just so they start tacking down. Oh, that guy's trying to get away. There we go. And we'll just let those solder joins melt, and they should just magnet into place. There we go. And I can just give that a nudge, and it moves back. Give that a nudge, and it moves back. Can we just get rid of that little bridge, just for tidiness? Yes, we can. There we go. And because I've got space here, I'm going to channel my Joey Does Tech and use a microfiber cloth with some alcohol on it, just to really clean that up nicely. This works great when there's space to do it, but I always find that I'm working in areas that are too cluttered for the microfiber cloth to fit in. Okay, right, let's put this back together again and see if it turns on. I've got to say, I really like the Series S as a console. Like, I know this wasn't the most powerful console in the world, but it was cheap. And the thing about the Series S is it's so easy to disassemble. It's a circuit board in a box, which is how, like, all the old style consoles were. And I really feel like this is the way that you should design a games console, because it's cheap and easy to fix and easy to manufacture. And I think just spiraling complexity on modern consoles is one of the biggest issues with them, which is why they're just becoming unaffordable. I don't see why the Series X, for example, couldn't have been just this, but bigger. Because that's all it is. It's just this, but bigger. So why not make it just bigger? You know, without having to do the tower engine block design that's nightmarish to assemble. You know, I don't know. That's just me. Right, that's the power supply in. So we've got to put like screws and stuff into the bottom of this, but I'm just going to very quickly rough fit everything just so I can see the front light come on and know that everything is going to work. Okay, power. And I'll push the power button. There we go. We've got a beep and a light and a fan spin. Excellent. There we go. We do have a picture. So that's actually just booted up just fine. So I'm just going to go ahead and hold down the power button now until it turns off, because that will tell it to actually switch off rather than go to sleep. I'm not sure whether, like, obviously what I should do is go and get a controller, plug the controller in and shut it down properly. I'm not sure how much they get upset if you hold down the power button. Pulling the power cord out is an unexpected shutdown, but I think holding down the power button, it will do a sort of a crash shutdown, if you see what I mean. Someone can tell me in the comments about that, whether that's like a mega crime or not, because I don't actually know. I've never seemed to have run into any trouble with that anyway. So that secondary power supply that we repaired, that was probably either the 5 volt or the 3.3 volt rail. I'm not sure which without looking up a schematic. I don't even know if schematics are available for the Xbox, if I'm honest. But again, this is kind of my point, is lots of people will always jump straight to schematics, but this is another example of a repair you can do without really knowing much about the device you're actually repairing. What you need to be capable of is recognizing patterns. You need to know what regulators look like, what a secondary power rail looks like. So when you're working on an unfamiliar device, you can spot those same things that you've seen in devices that you are familiar with and go, oh, this isn't actually all that different. So that's my spiel about that. And that's me trying to wrap in some kind of life lesson to a video that is fundamentally the same as all of my other videos where I replace a 22 microfarad capacitor. There we go. That's one blindingly white fixed Xbox. Thanks for tuning in, everyone. See you next time. Bye.